Halo, Assalamualaikum and selamat sejahtera. My name is Muhammad Faiz Abdul Rahman and I was supervised by Dr. Sohaila binti Sari and to our panels, Dr. Khalid bin Isa and Dr. Chu Chen Chun. So my title for final year project 2, enhancement of leak underwater image for visibility improvement. So this is a problem statement for our title, which is a image taken under low light condition, usually undetected with low light and de-hazing. And DSLR with high ISO still not able to solve this problem and challenging for checking underwater image or underwater environment. For lake underwater image, which is suffer from poor visibility due to attenuation of the propagated light and haphazard attenuation of the light underwater causes of foggy and misty appearance. So this is our objective for this project. The first objective is a proposed enhancement technique to improve the quality of lake underwater image, and second, develop a computer-aided system to clear the water particle in the lake underwater image. And the third objective is evaluate the performance of proposed technique. So this is my scopes for the project. First one is MATLAB software. Second, test image from lake in front of G3 intention. And third one is focus on lake underwater image. Okay, so now we go through on the lecture. Okay, now we go to lecture review. This is like from year 2015 is method color attenuation by year. Advantage for this method is faster achieve efficient processing when hazy image large, but limitation for this method is miscalibration will result in accurate estimation of the depth in some cases. In 2008, contrast maximization advantage is enhance the visibility of the image, and this method does not specifically improve the brightness of depth of the image. And the third one is 2008 independent component analysis, which is an advantage, increase scene visibility and recover haze-free scene contrast, but limitation for this method is unreliable because it does not work well for dense haze image. And 2011 reduction of fire, which is advantage single image is used for restoration of foggy image and transmission map is estimate accurately, and this method is invalid when since object is similar to a light. And then 2018 fast dehazing reduction of fire, which is a advantage image contrast reduction, thick haze removal, but limitation is increase the thickness of the haze when the haze in the image is not removed clearly. So now we go to previous contrast analysis method. At 2007 is contrast stretching. Advantage for this method is improve an image by stretching the range of intensity value it contains to make a full use of possible value, but limitation of this method is contrast stretching is restricted to the linear mapping of input to output values. The result is less dramatic but tends to avoid the sometimes artificial appearance of equalized image. And 2013 is multi-scale return X. The proposed method is used to overcome the limitation of single-scale return X. The method focuses on the luminance of the image, and limitation is execution time is less. And histogram equalization is simple and enhance contrast of an image. And limitation if there are values that are physically far apart from each other in the image. And the method 2016 discrete Gaussian transform. Each DCT possesses several traits that make it an effective tool for image compression, and the transformation is orthogonal. And limitation is input from pre-process 8 times 8 blocks are integer value. The output values are typical real value. And the last one is contrast limited adaptive histogram equalization technique, which is Krahi. The Krahi uses a contrast amplification emitting procedure that is applied for its neighboring pixel, which then form a transformation function in order to reduce the noise problem. And this limitation for this method is cannot be practically for large range of low contrast image. Okay, so now we go to the methodology. Okay, now we go to the project development. The first one, we start and study and review and do a system development and find result analysis and do a report writing. Okay, now we go to the first methodology is we use histogram equalization, which is HE. As we can see, the starting image we will input image in a RGB format, and then if we convert RGB image into the HSV, and we will divide 3, which is HVS, and apply to histogram equalization and assemble all the channels to the to form the HSV image and convert into RGB format back, and then we'll come up with output RGB image. As you can see, the image from this right, um, um, image that already enhanced by histogram equalization. So the second one for methodology is image enhancement technique, contrast limited adaptive histogram equalization. As you can see, this is output for Klahi after the enhance, and then as you can see, input from this the image which is original image and convert from RGB to ISS, and subjecting the image into Klahi and produce the histogram for each contextual region and clip the histogram according to the clip limit, and ISS converted back to the RGB, and we come up with output contrast enhanced image. And the result is will be like this. From original image, using Klahi, will be output this one. This is using method image dazing technique, which is using method that channel prior. This is original image uh, in forest. As you can see, the output of DCP is different from the original image. This one is starting from the input as image and do some dark channel estimation and add small space, light and transmission, and then go to scenes gradient and go to contrast adjustment and do sky masking, and then they will come out the recovery image. And then this one is first dazing that channel prior, and this one is visual inspection for that channel prior, first dazing that channel prior, which is like this is your original image and then the output of first dazing that channel prior. So this one is we input hash image and estimate at atmospheric light, and then transmission map estimation and transmission map refinement and image reconstruction, and we come up with output of the hash image. So for the methodology, we propose the hybrid from contrast enhancement to dazing, which is like we combine two methods to enhance the image, which is what's more suitable for underwater lake image. The first proposed method is histogram equalization combines Dutch and Empire. Firstly, we should um, input the image and then we'll perform a contrast enhancement, which is a do HE contrast enhancement, and come up with output. Okay, now we go to the proposed method 2, which is combination between histogram equalization and combines to fast dehazeing Dutch and Empire. And this one is still same with the previous method, which is do input image and perform contrast enhancement first, and we come out with the output image, and we perform dehazing, which is a fast dehazing Dutch and Empire, and this is the we come up with this is output image. So this is our proposed method 3, which is combination contrast limited adaptive histogram equalization, which is Klahi, combines with Dutch and Empire. And it's still same. We're using the flow chart, which is we perform contrast enhancement first, which is Klahi, and we come up with output image and perform dehazing Dutch and Empire, and we come up with the image enhancement from this method. And proposed method 4 is contrast limited adaptive histogram equalization Klahi, combine fast dehazing Dutch and Empire. Then this is for chart for this method, which is first we input the image and perform contrast enhancement Klahi, and from we got the output image, we perform the dehazing, which is fast dehazing Dutch and Empire, and we come up with this output image. So this is input underwater image late iteration at Z3, and this one is graphical user interface UI, which is that I created, and we will do some common analysis for contrast, which is a perfect perceptual substance index, which is PSI, root mean square, RMS contrast, luminance, and computational time. And now we go to now we propose this method 2, which is combination between histogram equalization combines fast dehazing Dutch and Empire. As you can see, this is after the result after do this combination for visual inspection for the three condition test image, and then this is performance evaluation, which is RMS contrast. In the RMS contrast, average for this method, is it not good enough between the previous method, but and have an good luminance and have a good sharpness, which is got highest value, and this method has been proposed because have a better than previous method, which is a computational time, which is to compute the image, which is take only 1 second to compute the image. And then this is proposed method 3, which is a contrast limited adaptive histogram equalization Klahi combines with the channel Empire. As you can see, this is the visual inspection for the three condition test image. And then this one, we are using Klahi because we need to getting high for RMS contrast and luminance, because we got a average between sharpness, because we only focus about sharpness, and then we must focus on the RMS contrast and luminance, because we want to get the highest average value between this method. Okay, and then But this method shows the computational time for compute the image take the longest time, which is in the 7 second. And then we do a purpose method for which is a combination between Kelahi combined to fast density induction prior. As you can see, this visual inspection for the three test condition image shows the detail one between the between the previous method. And then we do some performance evaluation, which is we got image contrast and luminance have a average for this method, and then the sharpness got the highest value of sharpness, and then we got a value for computational time, the take the shortest time between the previous method. So this method has an effective upper image enhancement from. So we do some discussion, which is from objective one is proposed enhancement technique to improve the quality of leak underwater image, which is an effective combination Kelahi and fast enhancing induction amplifier is proposed to give the best solution to for increased visibility leak underwater image. And then discussion for objective number 2, develop a competent aided system to clear the water particle in the lake underwater image. Okay, now we go to our discussion is the first one, which is objective. Objective one is propose enhancement technique to improve the quality of lake underwater image. And of course, we got an effective combination between contrast limited density histogram, which is Kelahi, and fast daisy induction amplifier is proposed to give the best solution to increase visibility lake underwater image. And then the second objective, develop a computer-aided system to clear the water particle in the lake underwater image. Graphical user interface is developed using MATLAB software. It could help the user in applying the proposed method and resulting method on the desired image, either to analyze or enhance the image. And then we do the third one is evaluate the performance of proposed technique. The performance evaluation of proposed method, which is a combination between Kelahi and fast dehaze induction amplifier, choose the lowest value primary contrast but the highest value of luminance, and perceptual sharpness index got the highest value, and also take a shorter time to compute the image. In terms of visual effect, proposed method produce filter image with a better quality. And then we go to the recommendation, which is there are some suggestions here for future project developer to improving the existing system. It is make a survey and get the number of respondents participating in the survey to increase the accuracy of the result in terms of visual effect inspection. And then obtain the image dataset with length to investigate the effective of the proposed method. And then the third one is updating graphical user interface to make it more user friendly. And then this is our conclusion, which is in conclusion, enhancement underwater image lake for visibility improvement has succeeded using an effective image enhancement hybridization between Kelahi and fast daisy induction amplifier has succeeded in achieving the objective. Thank you. But now, as you can see, you can go to demo. Okay, this one is a demo project. As you can see, uh, this method, this part is for dehazing method, and this one is for part contrast enhancement, and then this one is hybrid techniques, which is we only use for this method, which is contrast enhancement to dehazing, and this one, the fourth one, this one is from dehazing to contrast enhancement. Okay, and now we go the input. It's like, okay, now we test for in the forest image, as you can see. So using this, uh, we are doing that signifier, and then we got the result from here, and then this one is button pop-up for the image. Okay, as you can see, this is pop-up for the image. Okay, now and then this first daisy, this signifier, and this result. Okay, now we go to the our test image, which is like uh, with object, which is like, and then we go to the test image once. So we do a Klahi first. I take a shortest one, and then this is contrast the value, and then we go to HC button, which is the output, and then for the hazing, take a longest time, which is like, as you can see, the time. Now it takes 8 seconds to compute the image, and between the first hazing that signifier, which is only take 1 second, and then now we go to the our proposed technique and effective. So the proposed method one, which is HEDCP. That signifier take a longest time to compute the image, which is take 9 seconds, and then we go to the proposed method 2, which is HE and fast dehazing that signifier, and then this is our output for this of the test image one, and then now we go to the which is combination between Klahi and DCP, which is proposed method 3. Okay, this one the result for Klahi combination and with that signifier, this is take the longest time, which is 10 seconds, by any contrast and luminance shows, by any sharpness shows a good value, and then now we go to the our effective image, which is Klahi with fast dehazing that signifier. It takes only 2 seconds to compute the image, rather than the previous method, which is Klahi DCP, and then we show the contrast and luminance higher than uh, the previous method. Okay, that's all for me. Terima kasih.